Hello, Kim30, and welcome to your Q&A video from April 6th. You had questions, and I'm gonna answer them for you. So this is actually quite a long one. I'm gonna have timestamps in the description of the video, so you can go to the ones that interest you or that you're concerned with, but let's go ahead and get started. So first question that came up is I still get confused sometimes with the coefficients and subscripts when taking only some things from a whole reaction to make a half reaction. So I thought, hey, let's go through an example so you can kind of see that and we'll talk through it. So half reactions are always the lowest terms you possibly need, just like any balanced reaction, but it won't necessarily match what you would have in a normal reaction. Even looking at this example, maybe it's not the best. Maybe we actually come up with something else entirely, and I think we'll do that. When I come up with this reaction, we make it up just to note that it could have different solubility than what I'm going to write down, and that's totally fine, okay? I just want an example that has some weird coefficients. So let's say that we were reacting something like aluminum chloride, AlCl3 aqueous, and we're reacting it with, let's say, magnesium, all right? Mg solid. And we end up with then MgCl2 aqueous and aluminum metal. Now to balance this, I would need to have a 3 right here, a 3 right here, a 2 right here, and a 2 right here to make that work. Now, when I write out the half reactions, aluminum is going from a charge, and let's change the color here to kind of reflect this. Aluminum is going from a charge or an oxidation number, however you want to view it, of 3 positive to 0, while magnesium is going from 0 to 2 positive. Okay, so that's what I'm looking at in terms of numbers. So for aluminum, it's getting reduced. So I would write out Al3 positive aqueous, and it's getting reduced to aluminum, Al solid. Now you'll notice when I'm writing this, I'm not writing the beginning coefficient. Okay, I don't want to put that down because I don't know if that actually is going to be here in the end. And I don't do coefficients until the very end for a half reaction. So I'm going to leave it as it is. Now, even when I look at these subscript numbers, when it's an ion, I don't show that. Okay, so I'll do one more example after this, but I don't show those subscript numbers here because in an aqueous solution, it's individual ions. So essentially, both coefficients and subscript numbers do not carry forward unless it's a polyatomic ion like nitrate or chlorate, or if it is a element, right? The Hofbrinkel elements. Those are the only times I'm going to have subscript numbers carrying forward to the half reaction. In other cases, I don't carry those subscript numbers forward. So again, we only actually carry these forward if it's a polyatomic or an element that I'm doing that for, not for an ionic compound. So now that I've got that, I have 3 electrons on the left in order to make that work, and I'm finished. Well, for magnesium, I would have just Mg solid reacts to form Mg2 positive aqueous, and 2 electrons is how that would work. And again, I don't carry this 3 forward to here. Now, let's do a different example and see if that helps. So what if I go to a new page and I give you, we're going to use aluminum chloride again, but this time we're actually going to react it with oxygen, so O2 gas. Oh, 1 second, daughter at the door. And that makes for us AlO2, Al2O3, and sorry, I'm going to consider this aqueous, even though I know it's not, but for the sake of us kind of showing ions, we're going to do that so we can split it apart. And then I have Cl2 gas being produced. So I know states are wrong here, but for the sake of the example, let's stick with it. So I need a 3 here, a 2 here, a 4 here, and now I've got a 6 on Cl2, sure. Okay, so that's the different coefficients that I have. Now let's build our half reaction. So again, this was just me building the original example. Okay, now we're going to do the half reaction for this. So aluminum is 3 positive here. It is 3 positive here, so it's not actually doing anything. Chloride is 1 negative, and then it is 0 over here, and then here I have 0 and 2 negative, right? Or negative 2. So the oxygen is getting reduced. So now I'm going to carry this 2 into my half reactions. And the reason why I'm doing that is because it's an element, right? So that actually is what a molecule of oxygen is. But when I go to the oxygen, the oxide over here, that's going to be just O2 minus aqueous. Oh, put the 2 in the wrong place. O2 minus aqueous is what I've got, and then I need to have 2 of them by putting a 2 right there, and then I need 4 electrons on the left to make that work, right? So that would be my reduction half reaction, would be O2 gas plus 4 electrons makes 2 O2 minus. This 2 I put in afterwards in order to balance out the 2 O's in the reactants. Then when I take a look at chloride, again, I don't consider this 3 because it's in a compound, so I have Cl minus aqueous goes to make Cl2 gas, right? So I have Cl2 gas, I'm going to have 2 chlorides, and then I have 2 electrons over here to make that happen. The reason why I carry on this 2 is because Cl2 is an element. So again, only subscript numbers for polyatomics or elements are going to carry forward into the half reaction. All right, next question. The pH for compounds, elements, or ions. So this is about the Quizizz where the pH is greater or lower than 7. So essentially it's about this question right here. And the reaction to sodium metal with water, the reaction would produce, and then we have a bunch of options. So what this question is actually asking you to do is it's asking you to build a redox reaction, okay, by finding your SOA, your SRA, building the net, and then taking a look at the products and then knowing a little bit about pH to make that work. So my major entities are sodium and water. That's all I've got. Na solid, H2O liquid, right? So if I take a look, here's my Na solid, which is definitely my SRA. And then I have H2O, which is right here, which is the strongest OA that I have and the only OA that I have. So when I build this half reaction, I have 2 H2O liquid plus 2 electrons, gives me H2 gas and 2 hydroxides. So that is my reduction, right? That's my reduction half reaction. And then for my oxidation, I have Na solid, reading this backwards, produces Na positive aqueous and an electron. Okay, so I need to multiply this one by 2 in order to combine these. So I end up with 2 waters, 2 H2O liquid, plus 2 sodiums, 2 Na solid, makes 2 Na positive aqueous, an H2 gas, and 2 hydroxides. So the thing we care about is the fact that we actually made 2 hydroxides from this reaction, right? We could have actually not even combined this to a net. We could have just looked at this and realized, hey, I'm making 2 hydroxides. So what does hydroxide mean? Hydroxide is what makes a base a base. That's what makes a solution basic is its concentration of hydroxide, right? So if I were to look at hydroxide and bases, they have a pH greater than 7. So I know I'm making hydroxide ion, so it's one of these, and it has a pH greater than 7, so it's this one right here. Hydroxide with a pH less than 7, well, pH less than 7 actually means that it's acidic, so that doesn't make any sense with hydroxide. Does it produce hydrogen gas? Sure it does, but that doesn't cause the pH to change. Hydrogen gas doesn't do anything to pH. Okay, pH all has to do with hydrogen and hydroxide ions, which you're going to learn more about actually in a different chapter. So this will be easier once you learn chapter 16, which is all about acid and base chemistry and equilibriums. But it's still doable based on your Chem 20 knowledge, which is why it's on this quiz. So again, the best answer by far is this answer right here of hydroxide ions, which results in a pH greater than 7. I'm still slightly confused about the OAs and the RAs. I'm not sure specifically what you're confused about. Maybe it's just identifying what is what. I don't know. But again, remember that OAs are what get reduced, right? Well, RAs are what get oxidized. So reduction and oxidation, that's talking about the process it goes through. That's the name for the process. While OAs and the RAs, that's identifying the chemical that's going through the process. Okay, so when I talk about an oxidizing agent, it is causing the oxidation of something else. It's the agent for oxidation. And the way that it causes that is by getting reduced. So easy answer, OA gets reduced. RA gets oxidized. So this is identifying your reactant chemical that gets reduced is your OA, which means it's getting more negative, it's gaining electrons. And the chemical, the reactant that gets oxidized is your RA, which means it's becoming more positive, it's losing electrons. I don't know if that clears it up. If not, hey, ask again, just maybe give more detail about where your confusion is with OAs and RAs. Redox tables, like how to build them, I guess, which was something that came up quite a bit around the formal kind of assignment that's going to be worth a mark. So I thought I'd just throw in a question here and go through another redox table and see if that helps with some of the confusion. And let's see how that goes. I get that there is some tough stuff here. What I actually picked is I picked a question from your workbook, which is number 7, which was one of the harder questions. So we're going to go through this together and see what happens. So chromium 2 chloride solution reacts with aluminum. The only thing that can actually happen here, because it's chromium 2 chloride and aluminum, is that chromium is going to get reduced while aluminum is actually going to end up getting oxidized. So I have Cr2 positive aqueous. Actually, what we should do first, what I should be doing first is actually building all of our reactions and then taking that forward to build our redox table. So let's see if we can fit this on the two sides of the table. So we have chromium 2 chloride, so CrCl2 aqueous, reacts with aluminum, so Al solid. So based on your Chem 20 knowledge, you should know that this is going to be a single replacement and the metal will replace the metal in the ionic compound. So I end up with AlCl3 aqueous. Okay, and I'm going to have chromium solid as well. In order to balance this, I would need a 2 here, a 2 here, a 3 here, and a 3 here to make that work. Number 2, aluminum will not react if placed in calcium carbonate solution. So aluminum solid and calcium carbonate, CaCO3 aqueous, which truly isn't aqueous, but we're going to pretend like it is, makes, and I know it's not making it, but we're still going to finish this half reaction. It's going to give me solid calcium and aluminum carbonate, Al2. Oh, I made that ugly. Let's try that again. Al2 bracket CO3 bracket 3. Sure, let's make it solution aqueous. This does not happen. Okay, now in terms of balancing, if we were to make this work, that would be a 3, this would be a 3, and this would be a 2. For number 3, chromium 2 chloride doesn't react with zinc metal, so I have CrCl2 aqueous plus Zn solid makes, it doesn't happen, ZnCl2 aqueous and chromium. Okay, and then finally reaction 4, zinc metal and iodine crystals react, so they do react. So Zn solid plus I2 solid makes Zn I2, right? Balancing the charge, 2 positive, 1 negative, and I'm done there. And that does happen. This happens, this happens. Okay, so now that I've got that, I can start building my half reactions. And I get that this is tough. Predicting the reactions that happen, that shouldn't be tough. That should be review. That should be something that you are able to figure out. If you're confused about how do I know what the products are, well, whenever I have an ionic compound reacting with an element, the element will replace the thing in the ionic compound it's most like, right? So this is a metal element. It's going to replace the cation. Metals replace cations, nonmetals replace anions. So that is my reactions. Now I can take a look and try to figure out what the spontaneity will be. Or sorry, the table. I'm zoned out here. I got 2 positive. Okay, I got 0 for chromium, so it's getting reduced. And then I have 0 and 3 positive for aluminum, so it's getting oxidized. All right, so based on the fact that this is getting reduced, that is my OA. So I'm going to have Cr2 positive aqueous, and I know that is above my Al solid, okay, because my OA is above my Ra, it's downhill. So that's what that tells me. Now on this reaction, I have calcium 2 positive going to 0, so that gets reduced, so that's my OA, but it is not spontaneous. So Ca2 positive aqueous is below aluminum, giving me an uphill reaction. So again, non-spontaneous, which means uphill. And I know that this is an OA because it's getting reduced. It's becoming more negative. Number 3, chromium 2 and zinc. Chromium 2 is going from 2 positives to 0. So this again is my OA. This doesn't happen. So that means that zinc has to be above chromium 2 because again, it's uphill. It's non-spontaneous. So it's going up like this. Okay, and then finally, I have iodine and zinc, which happens. And now I gotta move this because it's a mess. Iodine and zinc happen, so I2 is going to be up here, giving me a downhill spontaneous reaction with zinc. So now I can finish off my half reaction. So I2 plus 2 electrons gives me 2I minus aqueous. Zn2 positive aqueous plus 2 electrons gives me Zn solid. Chromium 2 plus 2 electrons gives me chromium, Cr solid. And then aluminum will be Al3 positive aqueous plus 3 electrons gives me Al solid. And then calcium plus 2 electrons gives me Ca solid. So that's my redox table. Now what I can do is actually go back to my question here and just make sure, does everything match with what it should? So chromium 2 chloride reacts with aluminum. Chromium 2, aluminum. It's downhill. It's spontaneous. Aluminum will not react if placed in calcium carbonate. Aluminum, calcium ion, it's uphill. That's non-spontaneous. Chromium 2 chloride doesn't react with zinc. That is uphill. That's non-spontaneous. And zinc metal, and iodine react. That's downhill. That is spontaneous. So far, so good on that. So that's an example of a more complex redox table, quite complex because we actually have to build our reaction first, then analyze it, figure out what the OA and the RA is. And then again, like if it's spontaneous, what's happening is that my OA is above my RA. OAs always go on the left, RAs always go on the right. If it's spontaneous, it's downhill. This means it happens. If my OA on the left is below my RA, it doesn't happen. It's non-spontaneous. That's uphill. Okay, doesn't happen. All right, moving forward. For question 8 in the predicting redox reactions worksheet, are we supposed to know the chemical formula for vinegar? You don't actually need it for question 8, but you should know the chemical formula for vinegar. It's acetic acid. So vinegar is CH3COOH aqueous, and it's actually a very dilute solution of acetic acid. If you want, we can go through this question and you can see how that goes. So ammonium sulfate, right, means that I have NH4 positive aqueous and I have SO4 2 minus aqueous. I've got zinc nitrate, which means that I have Zn2 positive aqueous and NO3 minus aqueous for nitrate. Magnesium ribbon means that I have Mg solid. And then I've got vinegar, so CH3COOH aqueous. And then, of course, I always have water, H2O liquid. So now that I've got this stuff, I can figure out my OA and my RA is. So let me get a redox table here. Okay, so taking a look here at our redox table. if I start at the very top left and work my way down, the very first thing that I actually find that I have available is this for an OA, which is zinc 2. And then if I start at the bottom right and work my way up, the first thing that I have is the magnesium, the ribbon Mg solid. So I actually have this being my SOA, and then this is my SRA. So for reduction, I have Zn2 positive aqueous plus 2 electrons. Oh, I'm not in the right view. Oh well. Plus 2 electrons gives me Zn solid. And then for the oxidation, I've got Mg solid makes Mg2 positive, aqueous plus 2 electrons. And then for the net, I end up with Zn2 positive aqueous plus Mg solid makes Zn solid and Mg2 positive aqueous. This is spontaneous based on the fact that if I go back to my table, the Zn2 positive is above the magnesium, so that's downhill. It's a spontaneous reaction. Okay, so hopefully that answers that. So at the end of the day, should you know what the formula is for vinegar? Yeah, you should. You should know what it is. It's acetic acid. Now you do know if you didn't. Also called ethanoic acid. It's a very dilute solution of that. Was it the OA or the RA for this reaction? No, it's not. Okay, but anyways, there it is. Okay, half reaction needed for a titration question isn't on our data table, so you have to build your own. That can be confusing. So I took an example actually from your textbook to take a look at and kind of to show you how you would build your own half reaction. So here's an example where iron 2 solution is titrated to iron 3. So right away from this, I actually have a half reaction. I know that Fe2 positive aqueous is turning into Fe3 positive aqueous. And given that iron 2 is turning to iron 3, I'll need 1 electron on the right to make that balance out on both sides as 2 positive. So that is an oxidation. And then I have cerium 4 changing to cerium 3. So, oh man, is cerium Ce? I'm going to hope so. I'm going to check right after and make sure. But if it's not, I apologize. I just don't want to look. Ce4 positive to Ce3 positive aqueous. And then once again, it's 1 electron being involved here. So going from that to that, and then this to this. So all I'm doing is just taking the information and then using that to build my own half reaction and making sure to balance the charge on both sides by adding electrons to the more positive side as we go on. But normally it's pretty simple. You don't have to look at your redox table. You're just building it and moving forward. Okay. Nice to have some extra practice for Stoich. Well, page 600 of your textbook is really good. It has some questions you can try out. Some that give you the data tables and other ones that don't give you the data tables. So like different difficulties where you have to do different numbers of steps. So definitely check out page 600 of your textbook. And then if you look at the very back of your textbook, you'll have a small section there that has all the final answers. So you can see if you're correct or not for those textbook questions. So if you want more practice for Stoich, that's a really good place to start. If you're still struggling, the key, like the actual key book, is fantastic as well and has diploma style questions and stuff as well. If you don't have access to that, talk to me and I'll see if I can find you even more problems, which I'm sure I can. All right. So now we're kind of moving on to the not content type questions, but just like help around this whole new schooling. So I feel okay with the material when I'm watching the videos, but then when doing quizzes or assignments, everything seems new and confusing. Yeah, that's how it is when really learning anything, right? Is that it seems really easy when you're watching somebody else do it. But then once you're trying to do it yourself, you run into the pitfalls and realize that you are struggling. That's why it's so important to do the workbook, to check your answers and to learn from your mistakes. That's also why the Quizizz is there to give you direct feedback so that you can see where you have problems and again, go back and try to fix it. But applying your knowledge is tough, right? And that's different, actually applying it to quizzes and assignments. It's different than when you're actually applying it or just watching a video and doing examples, or even the workbook and then looking at the answers. It's a different level. And that's why we do it. That's why we do the quizzes. That's why we do the assignments, right? It's not just for evaluation for the assignments, it's for the learning. The quizzes specifically, it's for the learning of being able to apply it. I've had a lot of questions about or comments about feeling pressured about quizzes, and I get it. I get that it feels like pressure. That is just for feedback for you and for me. It's for me to see as a class, like, oh, we got 40% on this quiz. I need to reteach it. I need to go through things again. And it's feedback for you so that after you do a quiz, you see the mistakes you got, the things you got wrong, the mistakes you made, and then you figure out why and you fix it. If you're not doing that with your quizzes, there's no point. Okay, if you're not trying to learn from your mistakes, that it's not a good way to go about it. I am happier seeing students who get one or two questions right their first attempt, but then they keep on trying it until they get 100%, than seeing a student that passes it like 60 or 70% on the first try. I want to see you learning from the quizzes, and specifically learning from your mistakes. So they're set up for every single one to do them multiple times. Please take advantage of that and keep on doing them until you understand it and you get it. But yeah, that's how it is with knowledge. Applying is tough, right? And it's really easy watching me do examples. It looks super simple when I'm doing it because you're not seeing the pitfalls you run into or the misconceptions you have when you try it out, which is why we do the practice. It's why we do the quizzes. All right, that was long-winded. Moving on. So far, I'm understanding how to do the homework questions. However, when it comes to do the quiz, I find myself blanking because of the time limit. I've had to guess twice through all the quizzes because of it. Is there any way that it could possibly be removed? No, there is no way. I actually gave you or put in a screen from Quizizz when I'm building a quiz. It does not give me an option of no time limit. And in fact, it's really limited when it gets to the higher range where I have 2, 3, 5, or 15 minutes. I tried to choose a time that will give you enough time to do the question, typically, right, for an average student. I don't want to just go to 15 for everything because I think that gets a little bit ridiculous. And in terms of time, let that be a guide of like, here's how long it kind of should take to get it done. So if you're running out of time, maybe take that as a indicator that you don't know the information as well as you could, and that you might need to spend some more time with it. Now, I have an option to turn off the timer showing up, but then what happens is it just kicks you off the question and you have no idea why. So I find that that's even worse than having the timer showing. So I have the timer showing for people. But again, you can take this more than once. It's unlimited tries. So you run out of time on a question, well, review it after you're done the quiz, right? Figure out where your hang up was, fix it, and then go back and do the quiz again. I don't want this to be a pressure thing. It is for your feedback. Okay, that's it. And for me to figure out if the class is understanding stuff. This isn't something I am including in your average. I'll be honest that I might put it into Power School for me only to view and weighted as 0 so that I can just see how you have done on things, but that doesn't factor into your average at all. It is just my own personal record that no one sees except for me. So yeah, it doesn't factor in. It's not considered. Okay, don't worry about it. It is just feedback for me to see where there's issues with material, even specifically for you or as a whole class. And it also should be feedback for you to realize where you're struggling. Okay, so don't feel pressure about the quizzes. Please don't feel pressure about the quizzes. That's not the purpose of it. It's not evaluative. Okay, that's what the assignments are for. So that first Redox assignment, that is going to get marked. That will get considered in your average. That was a big deal. Okay, but you had the worksheets first, and then you had the quizzes to get you prepared for that, and then finally you had the assignment. So the idea is you go through multiple rounds of feedback before you're faced with actually a thing that's included in your average. All right, moving on. Confused how to learn like this. I'm confused how to teach like this, man. I don't know, right? Like this is a learning curve. I've said it before, I'll say this again, that this is really a good chance for you to learn how to be an independent learner. okay, for you to learn about feedback loops and stuff with yourself to make sure that you learn things and clarify things and get better at independent learning, which is critical in university and post-secondary. And I'll tell you this. There was a moment in one of my early math classes, right? First year, first semester, I was confused. I didn't understand something. I don't even remember what it was, but it was like something. Um, but there's this moment where I said, okay, I'm going to figure it out. And I went up and I found a spot in the library. Okay, one of the higher floors of U of C. They have tons of places where you can go and hide away from the world in the library. It's insane. But I think they changed it. But anyways, there used to be a lot of places. And I sat down with my textbook and I worked through problems until I got it, right? Were those questions assigned to me? No, they were not assigned to me. Did the prof even tell me where to look in the textbook? No, I had no idea. Okay, but I figured it out and I looked and I learned. Okay, and that was me being an independent learner, making sure, keeping myself accountable that I understood the class. And that's kind of like how this is. You have to keep yourself accountable and you have to learn the material and make sure that you understand it because you need this for later on, most likely. I don't know your plans, right? And I'm talking to a lot of people at once, but you need to hold yourself accountable and you need to be an independent learner. And this is a great opportunity to practice that with a few safety nets and stuff here for you as there normally is in high school. Like, for example, me hounding you when you don't get stuff done, right? So, yeah, instead of just letting you fail, collecting your money and saying, hey, register again so I can get more money, which is what post secondary does. So please use this, utilize it in order to get better at independent learning. That's really the key from this. And it's not easy. And it's really about you motivating yourself. But I get it. It's tough. All right. How will be graded going forward? Tests won't be accurate anymore. You're right. Tests aren't accurate. I can't give tests. I can't really give quizzes, right? That are summative, that give you a grade that's included in your average. You can't do that because I can't tell if people cheated or not. There's no way. So that is not how you're going to have your mark right now. My best option are the assignments, which is what I gave you that I can see, and that's going to go into your grade. Think about it as a take-home exam type thing. There's talk about later on maybe doing some kind of like a exit interview type thing. So that would be you have a scheduled Zoom time. We meet up and I ask you different questions, and one person might get questions different from another person to check understanding. Now, I don't want that to add to people's anxiety. I have no idea what it's going to look like. No clue. I just don't know. We're figuring that out. For right now, we're doing those assignments, and that is going to be included in your grade. And honestly, I'm also just looking at how you engage with stuff. I'm looking at if people are doing the check-in forms, if you are doing the quizzes, if you're doing your part as a learner. Yeah, that goes a long way. So just essentially right now, focus on understanding, focus on becoming a better learner, engaging in the material. And then those assignments, they're a big deal. Do a really good job on them. That's all I got for you right now. But we're going into the unknown here. And that's what I can tell you right now for grading. As time goes on, things might change. But you are completely right that tests and quizzes won't be accurate and we won't be relying on them going forward, at least not in the traditional sense of how we've done tests and quizzes in the past. What's a good way to stay motivated? I struggle with motivation as well. So I wrote down some things here to think about and consider and work on. But yeah, I mean, motivation again is tough. So here are some things that I can give you for this. Number one, do one thing at a time. People often try to do more than one thing, right? Like they'll try to watch Netflix and work on, an assignment, or they'll try to chat on their phone or Hangouts or whatever you cool cats are using these days. Snapchat, I guess. I don't know. And then at the same time, they're doing stuff. No, focus on one thing at a time and then get it done and then switch to something else. Multitasking sucks and it doesn't work. And the more you multitask, the worse you get at actually multitasking. Kind of a funny thing that the more your brain is trying to split its attention between two things, even if it's just switching back and forth between tasks, the worse it is at switching back and forth and focusing again. Focus on one thing at a time and just get it done. Tasks will take the time you give them. If you say, I'm going to spend all day to get this assignment done, it's going to take you all day. Set yourself a time limit for each task of, I think it's going to take this long, and then get it done within that time. So if you think, okay, it's going to take me, 2 hours to do this assignment, set yourself 2 hours and then get it done in that time. All right. But if you just say, oh, I'm going to get this done today, you will spend the whole entire day doing it because you're going to take a ton of breaks. You're going to work less efficiently, and you're going to take the time that you gave the task. Okay, another thing, set time intervals and reward yourself. Set an interval of, I'm going to work for this hour and then I'm going to watch an episode of something, right? Or I'm going to work for an hour and then I'm going to play like 20 minutes of a game. Okay, whatever. But set time intervals and then reward yourself after that, and then stick to it where you don't keep on going with the reward, but you go right back to working afterwards for another time interval. I actually am keeping, even I feel like this helps my productivity, I'm keeping a time log of what I'm doing each day for periods of time. I have it set up for 15-minute intervals. Okay, so essentially what I can do is take a look and record what I've been doing and keep myself accountable that way. And then I can look at that as an end product of the day and be like, hey, I'm proud of what I did, right? Because I completed all these different things. Another thing that I wrote down here, if I can make my mouse move, come on, you can do it. Make realistic goals and check them off. Start of each day, I make a few goals of I'm going to get this done, and then I check them off as I complete them. Okay, it feels good to check it off, and then you can actually see your progress as you go through. Even if you have small tasks, like I literally had on my list today, check email. Yeah, it's a small task, checking and responding back to emails. But it's still something that I did and needed to do, so I made that a goal, and I checked it off once I was done. Okay. That's all I have in terms of tips that I wrote down. I mean, the biggest thing for motivation is just getting started. Just start. That's the hardest part, is getting going. So do not start with a break. Don't say, okay, I'm going to do work after I watch 2 episodes of whatever. Okay, you are going to start first, get through an hour or a reasonable time interval of just doing that one task, and then reward yourself with an episode or whatever you want to do for 20 minutes, half an hour. Okay, and then again, an hour, and then a reward. But do not start with the reward. That is not the way to go. Just get started on the work right away. All right, I don't know, hopefully that's helpful, but that's some stuff that works for me. I think it's interesting for you to see how it worked out for the workload for Chem 30. There was 36 responses at the time of me taking this out of the video. And yeah, most people feel like workload for Chem 30 is about right now, which is good. So we're going to keep on going. You might have noticed that I actually kind of pulled back a little bit at the end of last week based on a lot of feedback from parents that admin was hearing that it was too much work. So we'll keep with the current pace that we're doing right now. I'm going to make a big plan of what we're looking at for a timeline till the end of the year during Easter break and figure out how we're doing, and then I'll adjust pace from there. But I think we're okay. Without having exams, without having the study time before the exams, without labs, we gained some time. Okay, so I know that we lost a little bit over a week in organization after all this started, but I think we'll be okay. But I'm going to get a hard timeline to make sure, and I'll get that done during Easter break. Okay, and then the last thing is favorite chocolate bar. Mine is Twix, and that is the only right answer. I think there were 2 people that put Twix. Good job. You have good taste in chocolate bars. The rest of you, be better. Yeah, eat a Twix. You'll like it. And then finally, yes, I did cut my own hair. Yeah, it was tough. Mirror image cutting the hair does not work out well. It's way shorter than I intended, but this is my reality, and that's what happens. Okay, that's the Q&A for this week. Yeah, hopefully that helped with some stuff. I will talk to you all later.